Hi guys, my name is Dr. Sean Connolly, and in this video we're going to be discussing the topic of hypothesis testing. The material I'm using is taken from this book, College Statistics Made Easy by Dr. Sean Connolly, and it's available on Amazon.com. Okay, in this chapter we demonstrate how hypothesis testing can be used to decide if a statement made about the value of a population parameter should be rejected or not. Specifically, we conduct hypothesis tests about a population mean and a population proportion. Now, I'd imagine you don't really appreciate what that means, but when we dive into this example, trust me, you'll know what I'm talking about. Okay, so let's start off. Hypothesis testing. An example. People spend an average of $200 a year on cinema tickets. In an effort to increase its revenues, the cinema industry undertakes an extensive advertising campaign. At the end of this campaign, a random sample of 150 cinema goers is selected and an average spend of $212 a year is recorded. It is known sigma is equal to $50. Has the advertising campaign increased revenues? Hypothesis testing is used to solve such problems. So just have a quick look, see that problem again? You've got the cinema industry. People spend an average of $200 a year. Now, obviously, the cinema industry would like to increase its revenue. So what it did was, it undertook an extensive marketing campaign. And you know, at the end of that marketing campaign, you want to know, has that marketing campaign, has it been a success or not? And that's what hypothesis testing is used to solve. Okay, pronunciations. Now, it's very important to be able to pronounce mathematical terms. Now, actually, when I say mathematical terms, that's incorrect. Very important to be able to pronounce symbols. So let's check this out. Pronunciation. H0 is used to pronounce H0. H1 is used to pronounce H1. Not very intellectual. Okay, at the end of the advertising campaign, one of the following statements is true. The average amount spent by cinema goers is unchanged and remains at 200 euros. In effect, the marketing campaign has been no good. The average amount spent by cinema goer has changed and is greater than 200 euros. Okay. In the context of hypothesis testing, one of these statements is termed a null hypothesis and the other an alternative hypothesis. So one's called a null and one's called an alternative. An explanation of both hypotheses is provided next. All right, let's check this out. A null hypothesis. The null hypothesis is a statement of no change, no difference, or no effect. The statement, the average amount spent by cinema goer is unchanged and remains at 200, is a statement of no change. It is therefore termed the null hypothesis. Other examples of statements that may be termed the null hypothesis are, let's check them out. The average sales of a shop remain unchanged despite an increase in floor space. The average age of clients remains unchanged despite an extensive advertising campaign designed to attract older clients. The average productivity of a factory remains unchanged despite the introduction of new work practices. Wow. So notation. The null hypothesis is denoted by the symbol H0. Examples in the use of this notation are provided next. Okay. So H0, the average amount spent by cinema goers is unchanged and remains at $200. Here's another example. H0, the average sales of a shop remain unchanged despite an increase in floor space. So H0 is just notation added to a statement. And do you know that statement? It's a rather boring statement. Nothing ever happens. Everything remains unchanged. Let me scroll back up. Let's look at these words. The null hypothesis is a statement of no change, no difference, or no effect. Boring. Okay, let's scroll down a bit. Let's look at this alternative hypothesis. Okay, the alternative hypothesis is the exact opposite of the null hypothesis. It is therefore a statement of change, difference, or effect. The statement, the average amount spent by cinema goers has changed and is greater than 200, is a statement of change. It is therefore termed the alternative hypothesis. Other examples of statements that can be termed alternative hypotheses are, let's check them out, people. One second now. The average sales of a shop has changed as a result of an increase in floor space. The average age of clients has changed as a result of an extensive advertising campaign designed to attract older clients. The average productivity of a factory has changed as a result of introducing new work practices. So, do you know, on the H1, I can see a bit of action goes down. Notation. The alternative hypothesis is denoted by the symbol H1. Examples of the use of this notation are provided next. H1. The average amount spent by cinema-goer has changed and is greater than $200. Here's another example. H1. The average sales of a shop has changed as a result of an increase in floor space. So we have two statements. One is called the null hypothesis, one is called the alternative hypothesis. The null hypothesis is a rather boring place. Nothing ever happens. It's no change, no difference. But the alternative hypothesis is where the action occurs. A change has occurred, a difference has occurred. Now, so we got two statements. Here we have a null hypothesis. Here we have an alternative hypothesis. The null hypothesis, we add the symbol H0 to it. And the other alternative hypothesis, we add a symbol called H1 to it. Okay, I got that. Okay, let's move down a bit. More pronunciation. H0 mu is equal to 200 is used to pronounce H0 mu is equal to 200. H1 mu is greater than 200 is used to pronounce H1 mu is greater than 200. And mu 0 is used to pronounce mu 0. Okay, let's read. The null and alternative hypotheses for the cinema example are stated below. Now remember, we call one H0, one H1. The one that's called H0 is termed the null hypothesis. Let's read. H0, the average amount spent by cinema goers is unchanged and remains at $200. H1, the average amount spent by cinema goers has changed and is greater than $200. More notation, people. Notation. Let mu denote the words average amount spent by cinema goers. Using this notation, the null and alternative hypotheses can be restated as H0 mu equals 200, H1 mu is greater than 200. Mathematicians, we don't like English words. We like to summarize information, nice, quick, and easy. I mean, check this out. Look up here. Here we have H0 and H1, and we have English words. The amount spent by cinema goers is unchanged and remains at 200. So what we said was, listen, Sean, that's a bit too long to write down. So, see this word, the average amount spent by cinema goers. We're going to replace that with the symbol mu. So come down here. H0 mu is equal to 200. I just read it out as H0 mu is equal to 200. Or I can read it out as H0, the average amount spent by cinema goers, is equal to 200. Let's go down to H1. Mu is the average amount spent by cinema goers is greater than 200. Nice one. So all we've done is, and by the way, we haven't gone into any mathematics or anything as yet. All we've done is replaced English sentences with mathematical symbols, which are a lot shorter. Okay, these statements may be read aloud as, I wish to test the null hypothesis that mu is equal to 200 against the alternative hypothesis that mu is greater than 200. In this example, the value of interest is 200. More generally, the value of interest is denoted by mu 0. So here I have a specific example where I'm talking about the number 200, but more generally, we denote it by the symbol mu 0. Now let's have it. Now here we formalized H0 and H1, but let's look at a few notes that the researcher might like to adopt when trying to write down H0 and H1. First note, when formulating the null and alternative hypothesis, the researcher should use the following points as a guide. Now let's look at A. The null and alternative hypothesis involving mu would always take one of the following 5 forms. Oh, nice one. So when you're researching your H0 and H1, when it involves just a single mu, will either be written as that, or that. Let's look at part B. From examination of note A above, we observed that the equality sign present in the symbols less than or equal to, greater than or equal to, and equal all occurs in the null hypothesis only. This is equivalent to stating that the equality sign never occurs in the alternative hypothesis. Check it out. Oh yeah, there we have an equals, there we have an equals, there we have a less than or equals to, there we have a greater than or equals to, there we have an equals to. Oh yeah. And what did you say again down here? You said this is equivalent to stating that the equality sign never occurs in the alternative hypotheses. Now remember, the alternative hypothesis is denoted by H1. No equal, no equal, no equal, no equal. Oh yeah, I get you. By the way, that's a no equal because it's not equal to. Just to summarize that again, the equal sign will always occur in the H naught. The equal sign will never occur in the H1. All right, let's go to point number 2. Consider the following hypothesis. All right, this is a different one. Scroll over, yeah. So, H naught mu is equal to 100, H1 mu is not equal to 100. The alternative hypothesis, by the way, the alternative hypothesis, that's H1, isn't it? The alternative hypothesis states that mu is not equal to 100. Hence, mu can be either less than or greater than 100. Yeah, it can be below it or it can be above it. This hypothesis is called a two-sided hypothesis, as mu can exist on either side of 100. Contrast this with the hypothesis, check it out. H naught mu is equal to 100. H1 mu is greater than 100. The alternative hypothesis, there we have it, the alternative hypothesis, states that mu is greater than 100. This hypothesis is an example of a one-tailed hypothesis, as mu can exist on only one side of 100. So, when we're stating our problem, we'll state the problem in terms of the null hypothesis, the alternative hypothesis. The null hypothesis we denote by H naught. The alternative hypothesis we denote by H1. We don't like big, long English sentences, so we like to replace them by short mathematical symbols. And we've learned that each test will either be a one-sided or a two-sided hypothesis. Okay, now let's go on to this next section here. Type.